Good. Okay, so it's been a month and some, and um, various things have happened. I'm just to say over on the food characteristics side, there's a paper coming together for that, and it won't be a paper in publishable form for the IFAO conference. It'll just be a presentation thing, but really it's something that I think could merit an hour or two discussion all on its own. Um, but we'll have to see. Anyway, both Roberts.
Sorry, Damien.
Yeah. Well, I was just going to
What
say,
is the deadline for that paper? I have to take a block of time and just.
yeah, okay, April. I think it's April. Let me just look on the food on site. Themes timeline. Okay, officially April 17th, but we'll probably add a week or two on that, as everyone else does. And right, so there's been some discussion, Rob, about food characteristics, and you were gonna target hops or I think it was beer in some cases, just to scope out the vocabulary gap or what you've got cooked up there. Um, and I am going to be working like crazy on it in the next couple of weeks. So I'm really happy about where that's going. Um, and so, Robert, Danny, if you want to take a peek at that, you're welcome to. I've just been inviting all the food on curators and others to chip in if they want under various sections, and Emily as well. Um, here's a link to it in the side channel. Okay, so back to food processing. Let's share screen. Okay, so more comments have flown in from people on this material processing fundamental terms document, and I think it's really going to turn into a paper. And so Sebastian started it off as a discussion piece, but we might as well transform it into a paper, I think. So for those of you who haven't seen it in a month or two, it's so far got some basic sections, the unwritten introduction, and then this section, material entity kinds. And this gets into the fact that when you say something is a part of something else, you might mean like a smooth mass noun parted, and that calls for certain kinds of relationships. Whereas if you're dealing with something that's composed of other things like a bag of cherries, then you might need a different relationship. So as we discuss the material processing pieces, some of them will be involving one kind of relationship and some will be involving another. So that's where we get into as well other relations like located and spatial, or maybe concentrations of things. So I should bold that. Just examples of relations. Okay, so then materials can have these roles, but I don't know that we would get into that unless these roles jumped out. OB already has some kinds of roles in it. I believe it has a reactive role. It certainly has this material to be added role. But now down to the processes. So part that I was just looking at was this material aggregation, which would be a new term. And it involves reorganizing a little bit what OB had in it. It had material combination as a top level. So Sebastian was sort of teasing out that we need a place for both adding materials together to make a new material, but we also need a place for adding something to something else, like adding water to a flask. And that's causing this hierarchy to juggle a little bit. So are you guys into just focusing, say, on this material aggregation branch, and as well trying to fit in material synthesis today? What do you think? That good meat to talk about? All right.
Perhaps you can show a diagram if you have already made some draft about it, because I think it is difficult to figure out what is the hierarchy from the list.
So I didn't update it, but yes, okay. So let's see if we can update this. So
so basically there is the bullet points in the black bullet points are the upper levels, and then the empty bullets are subclasses. But it is difficult to figure out what is the main branches, the main first level, I would say.
I agree. So let's toggle between the two, and right. And I'll share my whole screen. So we'll toggle back and forth, and I'll try to update this diagram real time. All right, we have material combination and addition, and we have this material aggregation. So here's addition, combination. Now we're looking at and material synthesis. And it was proposed that synthesis may be under, or maybe above a new term, material aggregation. And so and the material addition would be a peer. Now, to get some definitions in place, material aggregation, possibly material entity. In addition, actually, This is okay. Let's get the definition in place. Mhm. And then material combination. Let's just double check on the latest def. Single output. Yeah, so that is the latest def. Um, so um, and there's a question left in here about whether emulsions are included. So I'm going to just pop.
Yes, because my question will be then material composition transformation as subclass homogenization, and I think it's it should be clarified respective to emulsion effectively, actually, yes. Because so now what is a mixture in homogenization? It is a material combination or material aggregation or material addition? That's the question, I think. You have to give a definition for emulsion, yes.
Is sorry, first, is emulsification a verb?
No, it is a noun. Emulsification.
Is that a word?
Verb is emulsify.
To emulsify something, and then is the verb form emulsification?
Emulsify.
Emulsification.
Is a process. It is a result of the process, because you say me that a noun.
Well, an emulsion is a noun for sure.
But it is for me, grammatically, it is now a noun, either emulsification or emulsion. For me, they are both nouns grammatically.
All right.
Yeah, for emulsify to be similar to the other ones here, you could either say emulsification, and that's similar in syntax to combination and addition like you have, or you can make it emulsifying, and then it's similar to packaging and pouring and shaping like you have above. You have both syntax you have in here right now. They're both versions of the noun.
Right.
Emulsifying, yes, but the verb is to emulsify.
Yes. And all these boxes have a noun name, right? Because they're fixed. And I think emulsification is the most similar in syntax to the boxes around it.
Yeah, I like ing words for naming processes. So maybe homogenizing, emulsifying.
You could do that if you want, and then it would be it'd be adding and combining and so forth. Yes, I mean it's just, this is a bit of a style choice. They mean this.
Right.
I mean, technically, the grammar is if it ends in tion, it means the overall process.
Yeah.
And if it ends in ing, it means the current activity is happening. It's called a gerund, right, in grammar. But I mean, honestly, these differences are really, really subtle. Either one's fine.
Well,
my question was about the fact that homogenization or emulsification should be subclasses of either material combination or material transformation. I don't know exactly what you mean with the material composition transformation.
Yeah, I mean, I feel like if we're trying to figure out what lives under what here, what is the subclass and what is the superclass, I feel like we ought to always be asking ourselves in processing, in food processing, we ought to always be asking ourselves two questions. We ought to be asking ourselves an identity question and a physics question. The identity question is the thing that you have as an output the same identity or different identity from the things you had as inputs? It has to do with traceability and tracking and identifiers and sort of existence of things. And so therefore, like combining, you know, from an identity perspective, the thing that you combine is oftentimes the sum total of the two things that you put in, right? From an identity perspective. Or you may choose with emulsifying that the result is its own thing, which is physically distinct from the two inputs, right? The dressing is not just oil and vinegar. It is a new kind of thing, right? So, and then there's the physics. The physics of combining means that what you have is A plus B chemically, right? Or maybe in the case of emulsifying, it goes through an additional transformation. Whereas if you cut something, what you have physically is a smaller amount of the same thing physically. And that's what makes cutting physically different from combining, right? And so you're going to add attributes on these things that apply physics based on the nature of the process. You know that if you cut, you can take the content is the same, but the amount is less, and the surface area is more, and things like that, right? There's physics that we're going to apply on this, and chemistry as well. And so if you use those two big questions of identity and physics, or physics and chemistry, then I think you'll find that that tells you things about how to nest emulsification and homogenization and combination and addition with each other. I think that's the kind of logic we ought to be applying.
Mm-hmm.
Yes, and then I follow you perfectly. You are perfectly, I follow you. But then what is an emulsification for you?
Yes, so emulsification from an identity perspective, it is the sum total of the two things you put in. But from a chemical perspective, it's new and unseparable. And therefore, it belongs as part of the thing where identity-wise you combine them, but it needs to be a separate sub-branch because the output is not physically just detachable anymore.
And so in the material composition transformation, it implies that there is a change in the output composition. And in the material aggregation, can you, the identity and the physics you mentioned are two perspectives that are not the same. So can one class be a subclass of two different parents? One is material composition transformation, and the other is material combination. Can it be that it can be subclasses of both?
I think the cleanest way that we're always trying to balance complexity and or sort of accuracy and simplicity with these things. And I think the compromise here is to let identity trump physics, or maybe the other way around. But basically, say where you have things that have a similar kind of identity shift, they belong in the same branch. And then within that, if you have a different physics shift, those are different sub branches, something like that. I haven't worked this through yet, so I don't know if it scales what I'm saying, but I think it would be useful to try and minimize the super classes if possible, and not just have a proliferation of a whole bunch of things at the same level, but to try and have some leveling here. So what that would imply is the kind of combining where you still have separable results, like mixing salt and flour dry in a bowl, is different from the kind of combining where you can't separate them anymore because you've added water and you've dissolved things, or you've emulsified things, or you've homogenized things. That all those things have something in common, which is the inseparability post hoc. I'll yield the floor here a little bit. Rob, what do you think?
So I would go for physics first, personally, because physics is the one of the few things in this world we can rely on.
Yes, I like that.
And from then on, then I would starts this the specificity or an additional subclass for nomenclature or context.
Nice, nice.
Sorry, go ahead.
I'm just agreeing with you. I'm sorry to interrupt you with an agreement. And just to double on what you're saying, the physics of what happens to food is what makes the food processing ontology have a foodishness. And this is not just a sort of general philosophical set of processing or chemical processing, whatever. We want this ontology to work for us, to give us scalability and inference and so forth from a physics perspective, I think, even more than other things.
Okay, I'm sorry, Damien. I just had one last comment. I would push back on the idea of separation with respect to the flour and salt example. I think I understand what you want to do with it. It's just that I can see corner cases where it becomes very messy to determine whether or not, it's a separation is a process. It may be physical or chemical, and that strikes me as a little bit farther down the decision loop than where we are right now.
Good point. Good point. And therefore, maybe we're not quite ready to get into the nuances of the true taxonomic differences between, for example, dissolve, emulsify, and homogenize. That now we're starting to get into things that we're into very fine-tuning territory with those.
Well, I like the idea of trying to approach this as the physics thing, but then tag, if possible, that a process changes an identity characteristic.
I like that, Damien. That matches that matches my thinking. You guys are pushing me. In other words, an individual class here may have as its defining characteristic, or one of its important characteristics, the sort of the identity play.
Mm-hmm.
As part of it. Yep.
Yeah, or in fact, they may always. So let's see. Let's work this out with some examples here. So the flour one, adding flour and salt.
And Magali, I hope that this sort of slight generalization that I've introduced helps to guide us and doesn't just take us off on a tangent from where you wanted us to go.
I really try to follow you, but I do agree. My English is not so. I try to understand the different arguments you are both given. You have given, but I agree that with the physics first, we can better address the mechanism point of view. But I'm not sure I have understand what you said about separation can be physically or chemically obtained. So Warren, he was right also to when you say you push back identity, or I don't know, because I understand that you would prefer the physics perspective first to have the top levels, and then I am right, or?
Yes, I'm sorry. Sometimes I talk so fast. I get sort of excited in these conversations. Yes. I think the conclusion that Robert put on the table, which I strongly support, is physics is most important here. And
yes,
so
I agree.
in general, what that means for our discussion is if we're trying to figure out where a box belongs on here, we should first ask the question, how is this process physically different from the other ones or physically the same as the other ones? Yeah. And then on top of it, what I think we've discovered is the identity transference. Whether the outputs of a process are the same identity or different from the inputs is an important attribute of the process. And maybe it's confusing as a categorizer, but we should think about it as an attribute of these processes.
Yes, that's the change in it as characteristic change identity that Damien pointed out.
Mm-hmm.
Yes, okay. And then just a point for separation, which can be either physical separation or chemical separation. So you have both
yes.
possibility.
Right. And so what Robert cautioned me on is some things can be easy or hard to separate, and whether something then is separatable is a complicated question. And therefore, let's not focus too much right now on whether the results, the outputs, are separatable. When I see emulsify, one of the things I think of is you've combined things that are now hard to separate. But
Yes.
maybe I was giving too much attention to that attribute of the process. Let's go back to the simple idea of how is this physically the same or different from other things, and let's ignore some of what Troy just said.
Yes, it was about the example
Troy,
of power. Yes, because sometimes it is not a strict separation. You have some threshold, and it is not always black or white. It's sometimes also gray.
Yes, exactly. Robert.
no, Troy described it much more elegantly than I did.
But the most important is to agree.
Okay, well, I'm really enjoying this discussion. And I'm just putting a little diagram here to actually reveal, I think, something that often we're actually kind of jumping, we're actually lumping multiple processes into one. And sometimes maybe the answers are revealed when we actually pick these apart into little micro movements. So I just realized that pouring salt into flour, we need something called a striated substance. I bear with me here, folks. The act of mixing, often we bundle in the addition of something to something and mix at the same time, which is true. But
Not
then,
exactly the same thing for me to add something and to mix something, because you can add something without mixing it.
yes.
But if you are mixing something, you are obliged to add something. So otherwise you can't mix it.
So here's an example. I've just got a bunch of cherries and I've got olives, and I go and I add the olives to the cherries for some bizarre reason, and then I realize now I'm going to mix them up, or I realize I've added too many. Now I have to take out some olives. So there is an ability to add stuff, end up with a striated or differentiated substance that you can actually apply separation processes to in a different way from perhaps mixing. So I don't have food recipe examples right off the bat, but what that, yeah, just seemed that maybe that gets us to understanding that maybe we need some things called either some kinds of material entity name that are the product of homogenization versus emulsification. Emulsification, it's reminding me of this physics concept of entropy and chaos. You can mix things together, and then it's a lot of a different process to try to remove them apart again. So that's kind of a quality. I forget what the physicists call it, but the ability to undo a process, I guess, is also a characteristic. So an undoable, reversible is a characteristic of some processes and not others. That we'll want to hang on to. So some material combination processes are reversible and others are not. Okay. And that actually can help us tease apart things like emulsification, which is reversible. Is that right? Like at least some kinds of emulsification are reversible, and you could actually create subclasses. And I'm thinking of the salad dressing that you shake up, you emulsify, and then it settles out after a day or two. Is that right? in food?
I don't totally agree. It's a good point to see the reversibility, but I will not say that there is reversible emulsification or unreversible, because an emulsification is a state of it depends on the equilibrium. So just as you mentioned, it is not always stable. By definition, I don't know, Robert, you want to mention something? But yes, please.
Damien, I hear what you're saying. There's temporary, there's semi-permanent, there's permanent emulsions, is what Madeleine is referring to. Even if it's temporary, and as you're saying, your example, the vinegar and the oil separate visually. To separate them 100% would be near impossible unless you do a centrifuge or something like, so you could, but at that point, I don't know, just something, right? I mean, you can visually see them separate. To separate them, there are mechanical ways of doing that, but that would take significant, I guess it's possible.
Yes, and in the same kind of example, you can solution. Sometimes you think it is a mixture, a real mixture, but it is not. You have the solution, the dispersion, the emulsion. So you can't see it always with the eyes, but in the at the molecular level, you could. So it depends on the scale also. Yes.
Okay, that's helping. So maybe it's not that we just. Okay, Robert has a comment. I'll just slip in. Maybe it's not that we subclass processes as reversible, but rather substances as like permanently emulsified versus some other characteristic of the substance that indicates that it can actually separate out again. Rob.
I'm not playing devil's advocate when I ask this question. I ask because it has consequences for a few processes. When do we say something is reversible and when do we say it is non-reversible? And the reason I ask this is in the, water and oil, you can't separate it. It is doable. And other processes like grinding is completely non-reversible. There's no real way to do it. And then there's a certain chemical process where you can reverse it, but it involves an obscene amount of energy and effort to do it. So is there, again, I'm trying not to split hairs here, but is there something where we can say, is reversible something we're going to say is easily reversible, or is it something that easily reversible without heroic measures?
Right. Exact. Sure. Yeah, equals no energy aside from extraction, say. And by that, I mean, I've just mixed apples and oranges, and now to separate them out, all I have to do is pick out the apples. And that requires energy of extraction, but nothing else. It means separation of the object aggregate, of the aggregate objects. So
okay, so what I'm asking is our standard going to be excessive energy, and we believe that as as subject to interpretation?
yeah, so actually I think the answer here is in this object aggregate thing. Some of these processes are maintaining object aggregates and others are not. So
but it is not depending on the kind of action, it is depending on the level of energy, and it is not the same criteria
yeah,
to decide to have the reversibility or not. It is depending on the levels of energy you applied. It is not depending on the kind of process.
I agree there partly. I agree that pertains to a number of like chemical level reactions, or maybe even homogenization level. But now I'm understanding that there is this apples and oranges example, which is creating a process. Apples.
Oh, apples, juice, I don't know, orange. Okay, as object aggregates also.
Right. So both object, these things are object aggregates, and they create an output object aggregate. So that's actually a maintenance of a.
But each one, apples are keeping their identity, and oranges are keeping their identities too. But the resulting output is a mixture, is an object aggregate, which is a different kind of thing. That's the point. Object aggregates here, it's not a mixture. It's just two sorts of things that you have mixed. It is not physically mixed. It is just put together. But they keep their own boundaries.
That's right. So do we call that do we allow that to be called a mixture? And then we also have another kind of mixture, which is a noun, which is therefore not an object aggregate or chemical. What do you call it? Not homogenized, but a something chemical.
Okay, if I can jump in with three examples.
Yeah.
You know, let's on one hand, there's apples and oranges, and that's, you know, if it makes sense at face value. And then there's the example of, say, salt and flour, which is still separable, but no one in their right minds would ever do that because it's going to take forever.
Yeah.
And then the last example I have is people who do double cropping, and they will pour all of the harvest into a color separator, and you'll have two bins at the end, one with the beans and one with, say, the wheat. And all of those are the same three concepts, that they're aggregates, but there's this significant difference in how we look at them. And is there any possibility of having that written down somewhere where we say, yes, it is reversible, yes, it is an aggregate, but no, it's unreasonable? And there's something there. I'm just looking for an ontological or clean-cut way of making that definition.
Right. So case is totally still different. Go to reverse, and then other case, which is possible to reverse. And now suddenly I'm thinking of maybe extract, possible to extract something from.
Okay.
So not so much the reversing, but the potential to extract, and then you're calculating the energy of extraction and all of that. So I mean, it's true.
Okay, I like that. I think it needs a very long paragraph of description.
Right.
And also, if you go back to the previous document, I think we already have some definition for extraction versus purification and so on.
Yeah, to test whether they are actually.
Here, purification is under material separation, and extraction is not at the same level. It is because it is not the same bullet point, but perhaps it is wrong. The hierarchy, I don't know. because what is the difference between purification and extraction is the kind of the content in of some impurities, the degree of purity.
Mhm. Right.
To purify something, you have to do some extraction, but purification is a refinement. I think it is the difference is in the content of impurities or not, because you say extraction is separated from the reminder, but the reminder you don't know what it is, and then in purification you have some criteria to say it is pure or impure.
I would, seems to me that purification could be a subclass of extraction.
For me also, I have, because you have um, you are strict, you have a more strict criteria.
Yeah. Okay, so I'll drop a comment. Let's run that by Sebastian.
Yes.
Uh,
I think it could be a subclass also of purification could be a subclass of extraction. And then it would really be helpful to have so this distinction and definition, because it's also confusing in the real world to speak about separation or purification or extraction. So even fractionation, it is still without a clear definition. You can't. It is really helpful to have some definition.
Okay. So, well, that's where specific curation can happen to help it go beyond, say, the OB crafting of things. But maybe Magali, to make it real world though, is just about trying to generalize the language so other domains understand it. Is that right?
Yes, but I think it is very generic term, so it fits to OBI, but then we can have some example for the food. I think it was your intention also.
Yeah. Yeah.
Actually, Damien, if I can put an idea into this, we talked about energy earlier. Maybe we can, I'm looking at the purification and the sanitation use case. What if we use as the standard for reversible as the energy to separate it is not out of proportion to the energy used to put it together?
Mm-hmm. Yeah, good one.
So again, that I'm sorry, go ahead.
I like let's capture that anyway. Energy to separate is akin to energy to combine. That's one case. So when I think of the object aggregate, if there's a mixing thing, um, so you get a substance. You get one of two substances actually. So we've either still got an object aggregate after the mixing, or which has its own extraction possibilities, or you get a non, whatever we're going to call it, non-object aggregate, some sense, which is a much difficult more difficult extraction profile. So that transition from object aggregate to non-object aggregate. Is what some processes would be guaranteeing. Okay, this all, on the face of it, it all looks like another complex ball of wax, but at least being able to define some characteristics that we can apply to processes in this hierarchy is good. I'm getting the vision that maybe material addition
and just because I am not English native, I am always checking things, and I think you should write reversible and not reversible. I have just checked you. I put it in the chat. It's just a detail, but
okay. I'm just gonna get out of the here's chat.
And there are also some comments for purification with ultraviolet treatment. So, Robert, you can perhaps have some example.
The treatments ultraviolet. Yes, right. Okay.
Because I think it is dealing with the mechanism, either objectives or mechanism. I think it was also a good perspective to distinguish things.
I think that's
yes.
This is definitely material transformation, purification.
Yes, but the question of Robert,
sense.
perhaps you can say it, Robert, because you have also some sanitation process. I think sanitation is an objective, and applying chlorine in water is a mechanism, or at least a mean to achieve the objective.
Yeah. Okay. And indeed, a purification, I think what we would add there is, because done a little bit of work on filtration and defining filtration. Filtration is a kind of material separation. Purification is a little bit different because what you can be doing there is trying to kill off life forms in the water. And that is a material change. You're changing the life status of bacteria. So that is actually a material change. So I think we would create something underneath purification that would try to capture that for the case of sanitation. So I'll just note that.
Could that be that sanitation is a subclass of purification?
Yeah.
Because it is the same. You also want to remove impurities, but in that case, impurities are contaminants, are bacteria.
Yeah.
And in the same way, filtration that you mentioned, you can also have different kind of filtration. You can have a filtration to remove microorganism, or filtration to separate things chemically, physically.
Okay, yeah, some different concepts to try to weave together here. General point that a change in material composition can be as subtle as changing life status of bacteria in liquid. Or in the other cases, filtration is a more obvious case,
but here I can propose that we consider the physics because you have the separation from a solid from a liquid, or a solid from a solid, or a liquid from a liquid. You can consider also the nature of the two things you have to separate.
Yeah.
Either a solid or liquid or a gas, for example.
right. Okay. And that's on the separation.
And that would apply for separation, not
Yeah.
just for filtration.
Yeah. Separation. Synthesis, modulation, separation. Okay. All right. So we're coming to the end of the hour, and then I'll just move up here. This. Okay. Good. All right. So I think that's kind of a good place to stop. And I'll check in with Sebastian about some of the moves we're interested in making on the main document.
I've been slow on it, but I'm going to start cranking things out by early next week.
Yeah, good. Okay. Good enough progress on this call, I think. So let's wrap it up and talk in 2 weeks.
You take care and safe travels.
Right. Ciao.